So in this video, we are going to obtain the general solution of differential equations with homogeneous coefficients. So let's go ahead and solve our first problem. So for our problem number 1, we have x minus 2y differential x plus 2x plus y differential y is equal to 0. So notice here that both m and n are homogeneous and they are of the same degree, which is they are of the first degree. Okay, so therefore this solution applies to this differential equation. Okay, so what are we going to do? What's the first step? So the first step is to choose a substitution, whether y is equal to vx or x is equal to vy. So let's say I chose y is equal to vx. So if I choose y is equal to vx, then therefore I will also apply the substitution. Differential y is equal to v differential x plus x differential v. So let's go ahead and substitute that to our differential equation. So our x remains x minus 2. Our y will become vx, and then this would be differential x still. Then 2x plus y will now become vx, and differential y will become v differential x plus x differential v. Okay, so let us simplify the equation. I now have x differential x minus 2v x differential x plus, okay, distribute. Let's see, distribute this one first. So we have 2x v differential x plus 2x squared differential v, and then that one. So we have plus v squared x differential x plus vx squared differential v is equal to 0. So notice here that we can simplify some terms because they are like terms, so to say. So here we have 2vx and 2xv, both cancels out. And then notice that for our differential x, we have here differential x and differential x. Common term is x. Okay, so if we will factor that out, x times a quantity 1 plus v squared differential x. Okay, quantity x times a quantity 1 plus v squared plus quantity differential x. And for our terms with differential v, the common term is x squared. Okay, common term is x squared, and of course differential v. So factor out x squared, so 2 would remain here, plus v. Differential v is equal to 0. So as you can see here, we'll go to our next page. As you can see, we have arrived in a differential equation that can be solved using separation of variables. So let's go ahead and write that to our next page. X times a quantity 1 plus v squared differential x plus x squared times v plus 2 differential v is equal to 0. So let's go ahead and multiply 1 over x squared times 1 plus v squared. So what will happen to our differential equation? The first term will be differential x over x plus, then this second term will now become v plus 2v over 1 plus v squared. Okay, so as we can see here, the first term can be solved using simply by using logarithm, and the second term can be solved if we will separate the terms, which will become 1 plus v over 1 plus v squared quantity differential v plus 2 over 1 plus v squared. Okay? So, for our first term, as I've said, it will be ln x. The second term is also by logarithms. Your u is 1 plus v squared, so therefore the differential of that is 2v differential v. So you will have a balancing factor of 1/2. So ln 1/2 ln 1 plus v squared. And then the last term can be solved by arctangent. So 2 arctangent v is equal to 0. We can multiply 4. To our equation here and arrive at 4 ln x plus, or not 4, but rather 2, just 2. Okay, just 2 because of the 1/2. Okay, so let's go ahead and revise this. So we have 2 ln x plus ln 1 plus v squared plus 4 arctangent v is equal to 0. And then the last part of our solution is to combine the two logarithms and change v. Okay, since we have used a substitution, y is equal to vx, then therefore v is equal to y over x. Okay, so if I will combine these two, this will become ln x squared times 1 plus v is equal to y over x closed quantity squared. Okay, plus 4 arctangent y over x is equal to c. Okay, so this should be equal to c because we have already integrated, and that is our arbitrary constant. So let's go to our next page. You have ln x squared plus times the quantity 1 plus y squared over x squared plus 4 arctangent y over x is equal to c. Okay, so I will have here x squared times, let's get the LCD. The LCD here will be x squared, and the numerator will be x squared plus y squared. Okay, then what we can see here is we can cancel x squared. So our final answer will be ln quantity x squared plus y squared plus 4 arctangent y over x is equal to c. Okay, so you can pause the video before we go to our next problem. You can pause and you can rewind, but I will go to our next problem. So for our next problem, we will solve, let's say, quantity x squared plus y squared differential x minus xy differential y is equal to 0. Okay, so both of them are homogeneous and they are of the second degree. Okay, so we can apply the solution. The solution that we can substitute y is equal to vx and also dy is equal to v differential x plus x differential v, and then later on it will become a differential equation that can be solved using separation of variables. So let's go ahead. X squared plus v squared x squared, because it is y squared, minus x times v times x, and then differential y is v differential x plus x differential v is equal to 0. So we have x squared plus v squared x squared differential x. Now this would become x squared v. Okay, so if I will distribute that, I will have x squared v squared differential x minus x cubed v differential v is equal to 0. So it's very clear that these two terms are common and are like terms, and they have the same coefficient and they are subtracted to each other, so it cancels out. So we are left with x squared differential x, okay, minus x cubed v differential v. Again, it is a differential equation in variable separable. So if I will multiply simply x cubed, okay, I will arrive at differential x over x minus v differential v. This is a very simple. We will just apply the simple integration, and we will arrive at ln x times v squared over 2, and then is equal to c. So let's go to our next page and try to simplify. Let's try to simplify our answer, which is ln x minus v squared over 2 is equal to c. So let's multiply 2, as I have done, to eliminate the fraction. So this will now be 2 ln x minus v squared is equal to c. So 2c is still c, and then let's substitute v by, since we have used y equals vx again, so therefore v is equal to y over x. So minus y squared over x squared is equal to c. Okay, so that will now be our final answer. Now remember guys, in our class, so I will accept answers. My final answer will be always equal to c. That's the final answer that I will always accept. Okay, so we're down to our last problem. So our next problem number 3. So let's say I have xy differential x minus x plus 2y squared, quantity squared, differential y is equal to 0. So in our previous two problems, we always did y is equal to vx, but in this case, it is simpler if we could just use the substitution x is equal to vy, because differential x is simply multiplied to a single term, xy. Okay, rather than here, you have to expand x plus 2y. So both of them, by the way, are homogeneous, and both of them are of the second degree. Okay, so if we will apply the substitution x is equal to vy, then therefore differential x is equal to v differential y is equal to y differential v. Okay, so our x here will become vy times y times v differential y plus y differential v. Okay, plus y differential v. So minus x plus 2 times x will be substituted here by vy. I forgot that. dy. Then 2y squared times dy is equal to 0. Let's simplify our differential equation. So I have here vy squared, okay? So I will have v squared y squared differential y plus vy cubed differential v. And then next, let me expand this binomial first. So v squared y squared plus 4vy squared plus 4y squared differential y is equal to 0. So v squared y squared differential y plus vy cubed differential v minus v squared y squared differential y minus 4vy squared differential y minus, okay, everything will be in subtraction. So minus 4y squared dy is equal to 0. So there are terms that we can cancel. V squared y squared dy can be cancelled. So we have v y cubed dv as the only term with differential v, and here we have two terms with differential y. And the common term is 4y squared. So if we factor out 4y squared, we will now have v plus 1. Differential y is equal to 0. Okay, so let's go ahead and write that on our next page. So I have vy cubed differential v minus 4y squared times v plus 1 dy is equal to 0. So variable separable again, we can multiply y cubed times v plus 1, and we will arrive at the equation v differential v, okay, over v plus 1 minus 4 dy over y is equal to 0. Okay, so this term can be integrated using logarithm formula, and this one we will apply a technique. So let's apply v plus 1 minus 1 over v plus 1. So effectively we just added 0, but we have v plus 1 over v plus 1 differential v minus dv over v plus 1. Okay, so 4 dy over y is equal to 0. So this one, the first term, v plus 1 over v plus 1 is 1, so the integration is v. The second term can be solved using logarithms, so minus ln v plus 1, and also the last term, minus 4 ln y is equal to 0. So this should be equal to c. Equal to c. Okay, so let's write in our next page. So v, we have v minus ln v plus 1 minus ln y to the fourth is equal to c. Okay, so I have put 4 as my exponent. So next is we will apply the substitution. Since we use x is equal to vy, then therefore v is equal to x over y. So v is x over y minus ln x over y plus 1 minus ln y to the fourth is equal to c. Okay, I can combine the two logarithms. So that will be, I will first I will factor out the negative sign, then get the fraction here, get the LCD, so that will be x plus y over y plus ln y to the fourth is equal to c, and then combine. So that will now be y to the fourth times x plus y over y equals to c. So as you can see here, y cancels out. This will become y cubed. And finally, x over y minus ln y cubed times quantity x plus y is equal to c. So that will now be our final answer.